Good afternoon, I am Ian from the Cappy Express group, and today I am going to present the ABET project and how we design our concept for this ABET project. So, to design our concept for the ABET project, it is important to understand what we want to do. And we want to do a robot that is capable of moving a box from one place, in this case a grid, to another place, in this case a shelf. Considering this and considering some restrictions, as that some components were given or we should use some materials for the manufacturing of some components, or that we should consider some specification for our electronical circuits, there were several designs that we proposed, and we're going to go through three of them. The first one of them is the one on the left, and we have a robotic arm. As I mentioned, the mobile platform structure was already given, so we are not going to see a great change in it among the three conceptual designs. But in the first one, we can see a robotic arm. This robotic arm is a 3D degree of freedom robotic arm. We have a rotation at its base level, then we have a joint between two links to allow to function like an arm, like our arm. And finally, we have the gripper that will function as if it was our hand to relate it with us. However, this conceptual design has a big problem, and is that as we are going to use a LiDAR, the LiDAR sensor cannot have anything obstructing its vision. So if we have the robotic arm will obstruct the vision of the LiDAR, and that will be a problem. So we tried to look to another option, and this another option was the second one that is in the middle, that is a shovel that will pick up the ball. However, we still have the same problem. And what's the problem? That we are obstructing the LiDAR vision. Considering this and trying to propose an option where the LiDAR is not compromised, the third option, the one on the right, was proposed, and this consists on a gripper. A part of topics as materials that I mentioned that were already discussed previously, and also topics as that the mobile platform was already given, there are three key criteria that we should look for deciding which conceptual design is the better. If it is better to look at how we are going to manage the problem of the LiDAR obstruction of the vision, or if we are going to manage the problem of the gripper that among the three tools it has the less grappling. And considering this is that this matrix is shown where the three criteria are weight, as we want a light structure as motors were also given for the wheels of this mobile platform. Second, the LiDAR mapping, that is the thing that we have discussed the most. And finally, the grappling, as is obvious that the box should be at least slightly lifted and then move it to the final shelf. So, considering this, the conceptual design one is the one on the left, the robotic arm, the second one is the shovel, and the third one is the gripper. Considering the criteria weight, the robotic arm is the one that has the most weight, and as we want a light structure that is capable of moving boxes fast and having efficiency, it is not the best option. The shovel is lighter than the robotic arm, but not by much, so it's the second position. And the best one is the conceptual design tree, as a gripper is way more lightweight than the other two options. As discussed previously, considering LiDAR mapping criteria, both the robotic arm and the shovel are not great options. The gripper is, so this is simple. And finally, the grappling. As mentioned, the worst one is the gripper, as it is just two plates that are making pressure into the box to hold it. The shovel is a little bit better as it has some like a platform in the bottom that will help the lifting, and the robotic arm, considering that we can play with multiple plates to compress the box, will be the better option. All these results are summed up, and as seen, the best option was the conceptual design tree, the one with the gripper. And considering this, we are going to move forward into the architectures. These architectures are the functional, logical, and physical architectures. So the first one is the functional architecture. And the purpose of the functional architecture is for us to understand how the robot should work. So we are going to have different boxes that are going to display function of the robot. In the far left, we can see the function select box, sense box in shelf, and sense box in grid. Sense box, both in shelf and in grid, are for knowing which box we can pick from where. And select box is the human machine interaction to say, I want this box to go to this place. So the process can continue. With these three information, data is processed on a broker. This broker will then send the data to others mobile robots considering an internal clock. Also, this broker will display data in the human machine interface so we can know how the process is going. Going to the send data part, this send data is passed to the mobile robot, and this is not the only data that the mobile robot will receive, and it will also have integrated an RGB camera for identifying color, an ultrasonic sensor for measuring distance, and the lidar that we have discussed before for the mapping of the environment. All the data is processed so the movement of the car and the picking of the object of the box can be made. Then we have the logical architecture that is far more simpler than the functional and wants to divide the whole project into subsystems that make it clear what we should focus. We have 4 subsystems here. The senses subsystem, we have already discussed it before. A box in the grid or a box in the shelf should be sensed, and we should know where the box is. The request subsystem is on parallel of the sensing subsystem, as we need to know if we can pick a box or if a box is already picked up and moving from one place to another, mainly from the grid to the shelf. Finally, the control we have these 2 information go to the control subsystem that will process these data as we previously discussed and send the orders to the robot, to the car subsystem. So the mobile robot knows, okay, I need to go to this part of the grid, pick up this box, and then move into this other part that is the shelf and place the box in this position. Finally, we have the physical architecture that relates to every possible component that we have. We have a car subsystem because the mobile robot is just complex enough, so it is better to explain it as a subsystem, but we're going to start with the 2 places where the boxes will be located, the shelf and the grid. In these places we are going to have sensors, 9 because there are 9 boxes that could be fit, and these sensors will be activated or deactivated by this internal clock that we mentioned before by a relay. This relay is, we're mentioning that is activated by the PLC. This sensing of the boxes plus the sensors sensors of the car, that we are considering three sensors, as we are going to have three mobile robots. All the sensing process is passed to the PLC, so the PLC can first display data on real time to the HMI, and secondly pass it through Profinet and through a router, obviously, to the Raspberry broker. The Raspberry broker will be the main server where information will be located and where orders are going to be passed. So robot A should go to pick box B and leave it on the shelf D, while robot B should go to box A and leave it on the shelf G, and that's the same for the third robot. That's what Raspberry Broker will do. Will manage information and send individually the orders for each mobile robot. As we mentioned that we are going to have three, one per group. Finally, the car subsystem consisted of what we have discussed previously. The LiDAR that will give information to the Raspberry Pi. This Raspberry Pi will process LiDAR information, as LiDAR displays too much information for an ESP32 to process. However, we are going to use the ESP32 for the moving of the robot, that will consider the servo motors used for the gripper and the motors for the wheels. It is important to mention that here is also included the motor drivers for the motors, and also the ultrasonic sensor and the camera that were previously discussed. And that will be our project. Thanks.